Hello students, welcome you all to the solution session for GATE 2022 Strength of Material Civil Engineering. Moving on to the first question from Strength of Material. For a linear, elastic and isotropic material, the correct relationship among Young's modulus E or Young's modulus of elasticity E, Poisson's ratio nu and shear modulus G is. One mark question of GATE 2022 this is G is equal to E by 2 into 1 plus nu, B G equal to E by 1 plus 2 nu, C E is equal to G by 2 into 1 plus nu, D E is equal to G by 1 plus 2 nu. Students, this is a very fundamental question. Generally, the relationship between E, G and nu, Young's modulus, shear modulus and Poisson's ratio, the standard formula is G is equal to E by 2 into 1 plus nu. This is the standard thing. A very basic fundamental question is this from strength of material. So by the standard definition or standard formula, G is equal to E by 2 into 1 plus nu. Option A will be the right answer for the given question here. So hope you people have understood it. Moving on to the next question. Question number 2. Stresses acting on an infinitesimal soil element are shown in the figure with sigma 2 greater than sigma x. The major and minor principal stresses are sigma 1 and sigma 3 respectively. Considering the compressive stress as positive, which one of the following expressions correctly represents the angle between the major principal stress plane and the horizontal plane? Option A, tan inverse tau zx by sigma 1 minus sigma x. Option B, tan inverse tau zx by sigma 3 minus sigma x. Option C, tan inverse tau zx by sigma 1 plus sigma x. Option D, tan inverse tau zx by sigma 1 plus sigma c. Generally, whenever you draw the Morse circle, by considering some compressive stresses and positive and shear, which are going to give you anti-clockwise rotation as positive, the relationship, the circle will be, I'm drawing the Morse circle. Whenever we draw Morse circle, let this be A and the outer part is B. Now, to make you clear, whenever we take the points, this is the center point O, this is C, which will be the center. Let this be theta P, and the total angle here will be 2 theta P, and the inside angle here will be 180 minus 2 theta P, right? Somewhere you'll be having Q, and this is P, which will be sigma x minus tau xz. Sigma x comma tau xz. This is sigma z comma tau xz. This is sigma 3 comma 0 principal stress. This is sigma 1 comma 0, which is B. This is the Morse circle which we can give. Whenever I consider triangle ACP, this part, this one, the triangle is like, this is the triangle ACP. When you consider this triangle, this is sigma x, which will be equal to sigma 3 or sigma x minus sigma 3. Sigma x minus sigma 3. This is theta P as it is a point A. This is C, this is P. And this distance is around tau xy. This distance is around tau xy. So, from ACP. This triangle I have drawn now. From there, how can I write tan theta P? Tan theta P will be equal to tau xy by sigma x minus sigma 3. Since basically no sign convention of the shear stress is taken, so one can adopt negative sign for the given shear stress. So that case I'll write tan theta P is equal to tau xz by sigma 3 minus sigma x, right? Now I am considering triangle PBO. Triangle PBO. Triangle PBO, when you consider this, how this triangle will be? See, somewhere this will be the triangle, that is this is the condition P O B. This is totally 2 times theta P. This is 90 minus theta P. This is also 90 minus theta P. This is R. Right? This is the triangle PBO. Now, when we go for the next triangle, CPB, triangle CPB. This is the condition CPB, the total triangle CBP. Sigma 1 minus sigma x. This is tau xz. This is theta p. This is 90 minus theta p, which will be alpha. So tan theta p equal to sigma 1 minus sigma x by tau xz. So tan alpha will be equal to tan of 90 minus theta p from the triangle above. That will be tau xz by sigma 1 minus sigma x. Basically, angle theta p is nothing but angle of major principal plane from the horizontal plane, right? And concludingly, we can write alpha is equal to 90 minus theta p, angle of major principal plane from vertical plane. So, answer, what will be the answer for the question here? We have got around tan 90 minus theta p, that is tan alpha is equal to tau xz by sigma 1 minus sigma x. That will be sigma 3 minus sigma x. Obviously, option B, that is tau zx by sigma 3 minus sigma x. Option B will be the right answer for the given question. Option B will be the right answer for the given question. Moving to the next question. For a square steel beam of cross section shown in the figure, the shape factor about ZZ axis is S and the plastic moment capacity is M suffix P. Consider yield stress of 250 megapascal and A equal to 100 mm. The value of S and MP rounded off to 1 decimal are S equal to 2, MP equal to 58.9 kilonewton. S equal to 2 and moment is 100.2 kilonewton. S is 1.5 and moment is 58.9. S is 1.5, moment is 100.2 kilonewton meter. Generally, shape factor of diamond shape is 2. So, shape factor is moment about P by moment about Y. That is equal to Fy into Zp by Fy into Ze. that will be MP is equal to moment capacity S into My, that is S into My is Fy into Ze. Now, when we take the diagram, K, H, I, J, this distance, we need to know A, A, A and A. This will be root 2A. This is root 2A by 2. IZZ is equal to A power 4 by 12. Z is A power 4 into root 2 by 12A, that is root 2A cube by 12 cube, and moment capacity is 2 into 250 into root 2 into A is how much? 100 cube by 12, and convert them into or meter, 10 power minus 6, because he has given 100 Fy is 250, so obviously I'm converting it into meters. On converting it, I'm getting the answer of 58.93 kilonewton meter. 58.93 kilonewton meter, and shape factor is 2. So obviously the answer is option A for the given question. S is equal to 2 and 58.93 kilonewton meter. Option 2 will be the right answer for the given question. Moving to the next question. Which of the following statements is or are correct? If a linear elastic structure is subjected to set off load, the partial derivative of the total strain energy with respect to the deflections at a point is equal to load applied at the point. Yes, this is true. If linear elastic structure is subjected to a set off load, partial derivative of total strain energy with respect to load at any point is equal to deflections. Only the option A is reversed here, so obviously B is also right. If a structure is added up with the two forces of system PA and PB equilibrium separately, external virtual work done by the system of forces during the deformation used by other system of forces is equal to external virtual work done by a system, the deformation caused by a system PB. Yes, this is also right. Shear force in a conjugate beam loaded with a M by EI diagram of a real beam is equal to corresponding deflections. No. So simply option A, B and C will be the right answers for the given question here. 2 marks question. It is simple, very easy question. If you know shear force bending moments and shear centers and flexural stresses or deflection of beams, you can easily mark the answer here. A theoretical question for 2 marks, option A, B and C. 3 options are right here for the given question. Moving to the next question. Question number 5. Consider two linearly elastic rods HI and IJ of length B. As shown in the figure. The rods are collinear and confined between two fixed supports at H and J. Both the rods are initially stress-free. Coefficient of linear expansion is alpha. The temperature of the rod Ij is raised by delta T. The temperature of the rod Hi remains unchanged. The external horizontal force P is now applied at the node I. For a given alpha equal to 10 power minus 6 degrees centigrade inverse and delta T is 50 degrees, B is 2 meter and A is 10 power 6 Newton. The axial rigidities of rod HI and IJ are 2AE and AE respectively. To make the axial force in the rod HI equal to 0, the value of external force P in Newton is dash. Generally, the diagram shown to you, both ends are fixed. For axial force to be 0 in rod HI, axial deformation is how much? Axial deformation is 0. So F will be balancing due to the expansions in the rod Ij. Obviously, if I take the consideration of the rod P, which will be acting on rod Ij, this is rod Ij. So I'll write delta net will be equal to delta axial load plus delta temperature, which will be equal to 0. PL by E minus L delta T into alpha will be equal to 0. P is equal to AE into alpha delta T. So P is equal to 10 power 6 into 10 power minus 6 into delta T is given as 50. Conclude the answer from here. We will be getting 50 Newton. Thermal stresses question is this, very easy, 2 marks question. P will be 50 Newton. This is directly rounded off integer, so no problem. 50 Newton will be the right answer for the given question. By this, we have completed the questions of strength of material. Thank you, students.